Hello, the purpose of this video is to review a student's work or request for assistance, and I think everyone will benefit from watching this. So we're looking at exercise 8M, which is total surface area, always the most difficult of the mensuration problems. Because usually there is no real set formula, and you've got to carefully look at your diagram. They tend to be three-dimensional always. So if I look at the questioning, which is question one, as you see, this student has got basically identified. Let's go in. Has identified four triangles base times height, and if we look at the actual question, ah, question. That's question 1A. Yes, we have a tetrahedron, I suppose. That's a triangular, which has a total of four. And we're assuming, based on this diagram, that all sides are 6 centimeters. So when we do what's called a net, and you'll see more of the other two are more appropriate, uh, that we actually generate the following shapes. Uh, so we have a net, which is in this case a little bit more. So we got one, and we'll have another one coming off that, and another one coming off that, and the last one coming off that. And so you can see why the student has chosen that the three triangles, so four triangles, are base times height. However, and it doesn't come clear, the triangles in question, that six there is not the height of that, it's the length. It's an equilateral triangle. So we actually have to divide that into two equal parts. I'm going to have to use Pythagoras, knowing that this is only now 3. So we actually have to do an extra step for this one because we want the base. I'll go to a red pen. Let's go to pen, red pen. We want that to be the base, and we need that the height, which is unknown at the moment. So that's where the student has made a mistake. So using Pythagoras' theorem, I'll change to color so you can see that the extra part. So we've got a right angle triangle. We know that's 6, that was half that. And we want to know what h is. And so remember, the height of the length of the left side is a, which is the square root of c squared minus b squared, square root of 6 squared minus 3 squared, 36 minus 9 is equal to square root of 25. It's 25, and that's equal to 5. No, it's not. It's 27. You'd think that it would have been a nice round number. So we in actual fact have a surd. So the actual solution to this problem is yes. The area of that shape is 4 lots of base times height on 2. That's 4 lots. Yes, the base is 6, but in actual fact the height is 27 over 2. And so we end up with the 2's cancelling out, and we have 12 root 27, which is equal to 36 root 3, which is equal to 36 times 1.732. And you can work out the answer to that. So that was the trick to this question. The next question we'll look at is question B, which is a triangular prism. And here's what I mean by net. We actual fact have two triangles, where we are given the height and the base of the triangle. But we end up with also three rectangles. So it's appropriate that you do what's called a net. So that was a 5, 6, and 8. So going to our page, work. So, and I think that was exercise B. The student started on the work but didn't quite finish it. So let's have a look at that question there. So we remember we have a triangular prism. That was right angle. That was 5. That was 6. And that was 8. And what I mean by the net is if we open up, we'll have the two triangles. Then you'll have 1, 2, and 3 rectangles. So the net would look something like this. We have the 5 by 8 going with the 5 part of the triangle. We have the hypotenuse. So we do need to do some Pythagoras. And then we have uh, this length here. Oops, sorry, that's the 6 is there. And then we need the hypotenuse, which is that length there. So we have 5 centimeters, 6 centimeters, 8 centimeters, and this is the unknown, which is the hypotenuse. So we can see that these two are fairly straightforward. This one is also 5. This is 5 by 8. This one is 6 by 8. This one is half times base, which is 6 or 5 times the height of 6 or 5. Say 5. And we need to go away. So the calculations would look like this. Part 1, need a Pythagoras' theorem, where we have the base of 5, 6, and we need to find out c equals the square root of a squared plus b squared, square root of 6 squared plus 5 squared. 36 plus 25 is the square root of 61, which is a third. So the area of this shape is total made up of, so let's go back to the colour, red. We have one shape, 2, 3 different rectangles, and we have the triangle, and we have 2 lots of that one shape. So the surface area is equal to total surface area again is equal to length times width of shape 1 plus length times width of shape 2 plus length times width of shape 3 plus, remember, 2 times half base times height. So we have 8 times 5 plus 8 times 6 plus 8 times root 61 plus 2 times a half times 5 times 6. We have 40 plus 48 plus, I can't simplify that one, plus 30. So we end up with 118 plus 8 root 61. Oops. 8 root 61. Again, go away and use your calculator there. The next question I'll look briefly at is this trapezoidal prism. So it's got a trapezium as its base. And the trick here was the 5 centimeters. Remember, the area of a trapezium is A plus B times the height, which is that length there. So we don't use the 5, or certainly not for the trapezium. So you can see we have a rectangle, which is 5 times 12. And I'm assuming that side will also be 5 times 12. We have a top, which is 6 by 6, and the bottom, which is 12 by 12. So that's those 4 rectangles plus the trapezium, which requires us to go away and work out the height. Now, if we have that there, that's 6 and that's 12, and then these must be both 3 each. So obviously we're going to have to go away and do a Pythagoras' theorem again to work out what the height of the trapezium is. And the final question I would like to look at is the student began this one, almost got it right. What he had forgotten, of course, was that there. So if we go to his solution, let's go to his solution. So he's gone the pi rs because he didn't want the circle of the component of the cone. He's got the side of the there's the cone, which is cone pi rs, which is the slant height, which is good. We don't need to use Pythagoras here, and we don't have the base. Here is the side of the cylinder, which is 2 pi r h, but he forgot the base, which was the circle, pi r squared. So if we add an extra pi r squared, which is the radius of 7, and 49, that's about 120. That will get him up to about the 820 plus, which is in the solution. So have a go at those questions. Keep in mind, use a net. Be careful of some of the measurements. Don't assume them they are get plugged in straight into the formula. They may need Pythagoras. Cheers.